Hello, this is Mr. Miller, and I hope you're doing great today. This is video 2M, proving lines are parallel. We want to start with discussing conditional statements though. A conditional statement is a statement like this first one here. If a fruit is yellow, then it is a banana. We're not saying whether it's true or false, it's just the form of the statement. Sometimes they might be true, sometimes they might be false. But it has this pattern, if P then Q, where P and Q are some statements. All right, the first part here, the if part, if a fruit is yellow, that is known as the hypothesis. Okay, my writing's pretty bad here. And this part, the then part, sometimes the then isn't there, but the second part is called the conclusion. Okay, so the hypothesis is if the fruit is yellow, the conclusion is it is a banana. Now, the converse is a statement that's related to this. It's the one we get when we switch the hypothesis and the conclusion. So I'm going to try to type it here. So the converse of this would be if it is a banana, then the fruit is yellow. Okay, and again, converses may be true, they may not be true, but like I said, we're just understanding the pattern of the statement. So if we switch the hypothesis and conclusion, we get the converse. Let's try this one. If it snows, then school will be canceled. Well, the converse would be what we get if we switch it. If school is canceled, then it will snow. All right, let's try a couple more examples. Here's one. If an animal is a cat, that is the hypothesis, then it has whiskers. That's actually the conclusion. So the converse is what we get when we switch those. If an animal has whiskers, then it is a cat. That's not necessarily true. A lot of animals have whiskers. But that's the converse. We're not saying it's true. All right, here we go. Here's one from geometry. If a shape is a square, then it has 4 sides. That's certainly true. Let's write the converse, and I think you'll see that it's not true. Converse is if a shape, shape has 4 sides, then it is a square. All right, that's actually not necessarily true. Could be a rectangle or something like that. But you got the idea. I can take a conditional statement and write its converse. Okay, now there's some important converses we want to talk about. And these relate to parallel lines, the terms we have already discussed. The first example is right here. If 2 parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. We kind of know this one already. Like for instance, in this figure, if 4 and 6, well, if the lines are parallel, 4 and 6 have to be supplementary. That's the postulate. The converse states it the other way around. The converse of the same side interior angles postulate says, if 4 and 6 are complementary, then the lines are parallel. And that's a way we can prove the lines are parallel. If we know 4 and 6 are supplementary, we can conclude these 2 are parallel. All right, now we have 2 other theorems we've discussed. We have the alternate interior angles theorem. It says that if these lines are parallel, then alternate interior angles like 3 and 6 here have to be congruent. Well, the converse switches that. It says that if alternate interior angles are congruent, then the lines are parallel. So it works both ways. If the lines are parallel, alternate interior angles are congruent, or the other way around. If we know the alternate interior angles are congruent, then the lines are parallel. The last one is a corresponding angles theorem. For instance, angles 1 and 5 are corresponding angles. And we know if the lines are parallel, corresponding angles are congruent. Well, the converse switches that. It says that if corresponding angles are congruent, then the lines are parallel. Okay, so as I mentioned, converses aren't always true, but in this case, they are. So here are the three we just stated. The converse of the same side interior angles postulate, the converse of the alternate interior angles theorem, and the converse of the corresponding angles theorem. All right, let's see how we use these. So we're given this figure over here, so all the angles refer to this figure. It says, tell whether lines M and N must be parallel based on the given information. All right, they look parallel, but we want to know that we for sure can conclude that they're parallel. So what if angle 7 is congruent to angle 3? Well, if you look over here, 7 and 3 are alternate interior angles. So if they're congruent, then the lines have to be parallel. So that's true, they're alternate interior angles. So the reason why we know the lines are parallel is because of the converse of the alternate interior angles theorem. So if alternate interior angles are congruent, the lines have to be parallel. All right, check this out. If the measure of 3 is that, the measure of 1 is that mess, and x equals 8, how do I know they're parallel? Okay, well, if we substitute 8, we get that this is 142 degrees, and this is 142 degrees. They're congruent. That makes 1 and 3 congruent. 1 and 3 are corresponding angles. So if corresponding angles are congruent, the lines are parallel. That's the converse of the CA theorem. Okay, how about if 7 is congruent to 6? If 7 is congruent to 6, that's no good. So the answer to this one is no, we can't conclude they're parallel. If those were supplementary, the lines would be parallel, but since they're congruent, that's not enough. So they don't have to be parallel. All right, check this one out. What if the measure of angle 2 is this? The measure of angle 3 is that when x equals 14. Well, if you plug in x equals 14, you find out that this is 73 degrees, and this is 107 degrees. 73 and 107 is 180, so that makes 2 and 3 supplementary. 2 and 3 are same side interior angles. That does work. We know the lines are parallel by the converse of the same side interior angles postulate. Okay, so these converses are for demonstrating lines are parallel. All right, 2 more examples here. So what if this is the same diagram, kind of continuing the same thing. What if 5 is congruent to 7? 5 and 7 are corresponding angles, and if corresponding angles are congruent, the lines are parallel. And that would be the converse of the CA theorem. All right, this one, if measure of angle 6 is x plus 10, the measure of angle 2 is x plus 15, so it give me 2 and 6. Well, it depends on the value of x, right? They didn't give me a value of x here. So since those are alternate interior angles, if they're congruent, the lines would be parallel. So if x plus 10 equals x plus 15, that's never going to happen. They can't be congruent because when you add 10 to a number, it's not going to be equal to what you add 15. So this is no way. All right, because 2 and 6 would not be congruent, and since they're not congruent, the lines would not be parallel. Okay, now, one last type of way this can occur. This looks very much like problems we've seen. Normally, we're given that L and M are parallel, and we know these need to be supplementary. But this problem is kind of backwards. We don't know L and M are parallel, but we want to find the value of x that would make them parallel. So what has to happen is, in order for L and M to be parallel, these two have to be supplementary. So we need 2x plus 6 plus 130 equals 180. Looks exactly the same as the problems we've been doing. It's just the algebra is the same. It's the idea is a little bit different. Again, before we give you the lines are parallel and ask what x has to be. Now it's the other way around. What does x have to be for the lines to be parallel? All right, so 2x plus 136 equals 180. So 2x would have to be 44 if we subtract 136, or x equals 22. If x equals 22, this would be 2 times 22 is 44 plus 6. This would be 50 degrees. That would be 130. So by the converse of the same side interior angles postulate, since these are supplementary, we know the lines have to be parallel. All right, and that works when x is 22. Okay, now, this takes a little getting used to, but once you see what's going on, this won't be too hard. I just have two questions for you. They use this diagram here. They want to know, first of all, what kind of angles these are. So we're talking about 3 and 6. So tell me what kind of angles 3 or 6 are. And if they add up to 180, why do we know that these lines are parallel? Well, the answer is one of the converses. I have them right here for you. Then, for the second problem, what about 2 and 6? What kind of angles are 2 and 6? And if they're congruent, why can I conclude that the L and M are parallel? And again, it's one of these converses. All right, so tell me what kind of angles they are and which converse we use to show the lines are parallel. All right, good luck.